So guys, you are welcome to this lecture. Now in this lecture we are going to look at the derivatives of monosaccharides, disaccharides, and then we are going to look at polysaccharide. Now to begin, when we talk about derivative of monosaccharide, what do we mean? Now we have a statement here, derivative of monosaccharide. We can split it down into derivative and then monosaccharide, of course. Okay, derivative and then monosaccharide. Now when we say derivative, it means gotten from. Derivative means what? Gotten from, drawn from, or we can simply say derived from. So if we want to link this with what we have here, gotten from, drawn from, or derived from, so we can now say that the derivative of monosaccharide are those things, those compounds, or the families of compounds that are gotten from what? Monosaccharide. Maybe by oxidation, maybe by removing one or two things. Are we getting it? That is what derivative is all about. It could be by reduction, it could be by removal of one or two things, it could be by just like a modification of what monosaccharide is to give something else, but still retains most of the features of what? Monosaccharide. But still retains most of the features of what? Monosaccharide. Now, let us look at the derivative of monosaccharides to start with. Now, the derivative of monosaccharides are sugar acid, sugar alcohol, amino acid, deoxy sugars, and L-ascorbic acid. Now, L-ascorbic acid is what everybody commonly known as what? Vitamin C. It's not a carbohydrate. It's not a carbohydrate, but it has a structure that is similar to the structure of carbohydrate. And then for this lecture, what I'm going to do is I'm going to talk about the sugar acid, sugar alcohol, amino acid, and then deoxy sugars. And then what you are going to do for me as an assignment is to get me the structure of vitamin C and then write a short note on vitamin C. So let's dive right into the lecture. We have sugar acid. Now, how do we actually get sugar acid? Now, if you oxidize aldehyde or primary alcohol, what are you expected to get? Now, if you normally in organic chemistry, this is an aldehyde functional group. This aldehyde. Now, if this aldehyde is oxidized, let's say using an oxidizing agent, potassium permanganate, potassium chromate, chromic acid, etc. When you use this oxidizing agent to oxidize this, what is happening? Now, oxidation means the addition of oxygen or removal of hydrogen. One oxygen, of course, will be added to this OH, and then we are going to have arrow C, double bond O, and what? OH. You now see that one oxygen has been added here because oxidation means addition of oxygen. Oxidation means the addition of what? Oxygen. So this case now, this is an aldehyde. What is this? Aldehyde. And this is a carboxylic acid, or we can just say in short form, this is an acid. Okay, so whenever aldehydes are oxidized, what are you expected to get? You're expected to get a carboxylic acid. Now, secondly, whenever, so we say aldehyde can be oxidized, aldehyde can be oxidized to give us carboxylic acid. Okay, we say this is aldehyde, and then oxidizing agent can be anything to give us what? Carboxylic acid. Okay, now in same way, primary alcohols can also be oxidized. Now, what is the structure of primary alcohol? Primary alcohol are those alcohol that has two hydrogens attached to the carbon carrying the OH group. They have two hydrogens attached to the carbon carrying the OH group, or they have just one alkyl group. Now, this you have here is an alkyl group. This arrow group here is an alkyl group. So if it has just one alkyl group attached, we say that is a primary alcohol from our knowledge of organic chemistry. Okay, so when this is oxidized also, first of all, this primary alcohol will get to become an aldehyde. And of course, if the oxidizing agent is a very harsh one, if the process is not controlled, this aldehyde will simultaneously change to form what? A carboxylic acid. So you see the series of reactions that it goes through from a primary alcohol. Now, primary alcohol is 1 degree alcohol. Primary alcohol is what? 1 degree alcohol. If it's oxidized, if the process is controlled, that is why we say it is controlled oxidation. It will first of all give an aldehyde, and then from there, the aldehyde will be further oxidized to give us what? A carboxylic acid. To give us what? A carboxylic acid. So this is carboxylic acid. Now, if the process is not controlled, if it's uncontrolled, it means that the primary alcohols can be oxidized directly. This 1 degree alcohol, when I say primary alcohol, I mean 1 degree. When I say 1 degree rather, I mean primary alcohol, will be directly oxidized with strong oxidizing agent such as K2CR2O7, potassium heptazoldichromate, to give what? To give a carboxylic acid directly. Are we getting it now? So uncontrolled oxidation of primary alcohol will give a carboxylic acid. This 1 degree alcohol. I told you that whenever I say 1 degree alcohol, I'm talking about a primary alcohol. So this will give us carboxylic acid, or this will form a carboxylic acid. So to say, now if you look at the structure of most monosaccharide or structure of most carbohydrate, we said carbohydrates are either aldose or ketose. That is to say, they contain either the aldehyde group or the ketone group. So it means that the aldehyde group of the carbohydrate can be oxidized to give us a carboxylic acid. Hence, we form the derivative called the sugar acid. So sugar acids are formed by oxidation of the aldehyde group, which is this group of monosaccharide, to give carboxylic acid, or the oxidation of the alcohol group, primary alcohol, most time found in position number 6, or for glucose, to give what? A carboxylic acid. So this primary aldehyde group can be oxidized to give a carboxylic acid, which is called the sugar acid. Also, alcohol group can be oxidized to give a carboxylic acid. So if we come back here, let's look at this. Now you agree with me that this is the aldehyde functional group. True or false? So it means that this can be what? Oxidized using oxidizing agent. Now, if that is oxidized, what are we expected to form? Now listen. When this group, which is this aldehyde group, is oxidized, when this aldehyde group is oxidized, what you will form is called a gluconic acid. For instance, that of glucose, it will form what? A gluconic acid. Okay, gluconic acid. So whenever the aldehyde group is oxidized, what are you going to form? Gluconic acid. For instance, if you look at these two products that are formed here, look at them very well. You agree with me that this one is being what? Oxidized. Because what we have here, this functional group we have here, is a carboxylic acid functional group. True or false? This is a carboxylic acid functional group here. So this is a sugar acid. And the name of this sugar acid is called gluconic acid. It's called what? Gluconic acid. Now, in the same vein, we also said that the primary alcohol group, which is at position number 6, can also be oxidized. The primary alcohol group can also be what? Oxidized. So if the primary alcohol group is oxidized, what are we expected to form? Now, look at what we had here. We said when the primary alcohols are oxidized, it forms a carboxylic acid, which is ROCOOH, where this R is the alkyl group, which is the attachment to the what? To the chain. So if we come back here, we can now say that this carboxylic acid, this alcohol group here, which is a first degree alcohol, can also be oxidized to give a sugar acid, which in this case is the first structure here. So you see that in this first structure, the aldehyde group remains the same, but what was oxidized is what? The position number 6 to give us the carboxylic acid, which is sugar acid. So if it is the position number 6 alcohol that is oxidized, you call it glucuronic acid. You call it what? Glucuronic acid. Okay? Call it glucuronic acid. So that is for the oxidation of that is for the oxidation of monosaccharides to form sugar acid. This glucuronic acid. So whenever the aldehyde group is oxidized, what you form is gluconic acid. Then if the position number 6 is oxidized, what you form is what? Glucuronic acid. Okay, so that is for sugar acid. Okay, sugar acids are formed when either the aldehyde or the alcohol group at position number 6 of a monosaccharide is oxidized. Please take note of this. Okay, the next thing we are going to look at is sugar alcohol. Now, how do you think sugar alcohols are formed? Now, we said whenever aldehyde are oxidized, what will they give to us? They will give us carboxylic acid. And I said something also that whenever primary alcohols are oxidized, first of all, if it's a controlled process, it's going to give us an aldehyde functional group. Are you getting it now? Now, in the same way, an aldehyde functional group can be reduced using any of the reducing agents. So I may say reduction. Now, when it is reduced, reduction is just like the opposite of oxidation. Reduction is just like the what? Opposite of oxidation. So if something is not reducing, it's oxidizing. That's why you call it redox reaction. Redox for red, and then oxy for oxidation. Redox, ox for oxidation, red for reduction. Are you getting it? The two processes go simultaneously. So in this case now, what are we going to get? When this aldehyde group is reduced, what are we expected to have here? You're expected to have what? You're expected to have the alcohol, because it's the opposite of what you have here. So whenever alcohols are oxidized, they give aldehyde. Whenever the aldehyde are reduced, they give what? Alcohol. So sugar alcohols are gotten when this group here are reduced, which is this aldehyde group here is reduced. So whenever the aldehyde group is reduced, what is formed is sugar alcohol. And we discussed something like this before now, where we said that glucose is going to form sorbitol, mannose is going to form mannitol, galactose is going to form docitor, then what is it called? Fructose is going to form something and something. The ribose is going to form ribitol. Are we getting it now? We did all this before. So whenever the aldehyde group is reduced, what we form is an alcohol, which is called a sugar alcohol. So this is a sugar alcohol. You see that in this sugar alcohol, it has no, what will I call it? It does not have the aldehyde functional group nor a ketone functional group. All what it has is an alcohol, CH2OH, OH. Is that understood? So this is glucose. This is structure of glucose. Okay. Now, what do you think glucose will form? Glucose will form sorbitol. We discussed this before, right? We discussed it before. So that's for sugar alcohol. Now, let's look at the next one. The next one is amino sugars. Next one is what? Amino sugars. Now, amino sugars are formed when one of the alcohol group, for instance, you have this OH group here. Let me use a different color to indicate. Red again. Now you have this OH group here, right? when this OH group here is replaced, when the OH group is replaced by an amino group, it forms an amino alcohol. It forms what? An amino alcohol. For instance, this is the structure of glucose. We always use glucose because it's very common. Now, when the OH group of glucose is replaced, if you see this new structure here, what are you having here? Not longer OH, but what? NH2. You form what is called glucose amine. You form what is called what? Glucose amine. What do you form? Glucose amine. Okay? So that is the structure of glucose amine. Now, the next one, the oxy sugars. Now, what is the meaning of DNA? If I may ask, everybody will say DNA means deoxyribonucleic acid. Deoxyribonucleic acid. Now you are going to look at this later chapter, right? Let's not rush into that. But now when they talk about the oxy sugar, to this word D means what? To remove, right? For instance, we say activate, deactivate. This activate means to put into activator, to put it on action, right? Deactivate means to what? To remove, right? To remove. So the oxy sugar means you are removing oxygen. The oxy, the main word here is oxy. You are removing oxygen. Deactivate, removing activation. Deoxy, removing oxy. Oxy means what? Oxygen. Oxy means what? Oxygen. So when you remove the OH, especially from number 2, you call it what? A deoxy sugar. Are you getting it now? You call it a deoxy sugar. For instance, this structure here is what structure? What structure do you think is this? Is 1, 2, 3, 4, 5, 6. This is fructose, right? Now you can have the structure of ribose, and then when you remove the H, it becomes deoxyribose. But this one is what? Fructose. The structure of fructose. Are we getting the Pirano structure of fructose? So you can say this is what? Deoxyfructose, whichever way you want to call it. But this is deoxy. And most time, the deoxy or removal of oxygen is usually at this position here. Are we getting it? Usually at this position number 2. So that is that for deoxy sugar. It's very simple. Whenever I remove oxygen, it forms a deoxy sugar. Now the next one is ascorbic acid, which is vitamin C. I told you are going to work on ascorbic acid, right? You are going to work on ascorbic acid, which is vitamin C. So that is all about the derivative of monosaccharide. So can we state the derivative of monosaccharide now? Can we go together? We say the derivative of monosaccharides are sugar acid, sugar alcohol, sugar acid, sugar alcohol, amino alcohol, deoxy sugar, and then ascorbic acid. Let's see if we get them correctly. Look at it here. Sugar acid, sugar alcohol, amino sugar, deoxy sugar, and what? Ascorbic acid. L-ascorbic acid, which is vitamin C. So you are going to give me some notes or details about vitamin C, especially the structure of vitamin C. Especially the what? The structure of vitamin C. Is that understood? Now, so that is everything about the derivative of monosaccharide. What can be gotten from monosaccharide? Now you see that each of them that we discuss, you see that something is added or something is what? Removed. It is being modified, but it still retains the original structure. But the functions will differ. Are we getting it? For instance, you cannot say the function of vitamin C is the same with, or the function of an amino sugar is the same with function of glucose. It doesn't work like that. Is understood? So the functions will differ, but the structures will always be almost the same. Just maybe a slight modification in one or two of the atoms present there. Is that understood? Yes, I guess. So let's move ahead to the next thing. The next thing we are going to look at is glycosides. They are medically important glycoside, but how is the glycosidic bond formed? How is the glycosidic bond formed? Now, the glycosidic bond is formed whenever the alcohol group of one carbon of one monosaccharide. This is a monosaccharide. Let's give the name of this monosaccharide. This is what? Glucose. Are you getting it? React with the alcohol group of another monosaccharide, which in this case is glucose, to eliminate water. To eliminate what? Water, forming a bridge of oxygen in between them. Now, this kind of reaction in organic chemistry is called a condensation reaction. This reaction is called what? A condensation reaction. It's called a condensation reaction. Now, the question may now be, what is the usefulness of this reaction? Why, when two molecules come together, what are we expected to get? Can we think? What are we expected to get if two molecules come together? Now, we are expected to have a larger molecule. So, condensation reaction is the coming together of two small molecules to form what? A larger molecule. Coming together of two small molecules to form what? A larger molecule. With the elimination of another small molecule, like in the case of water. So, in this case, water is being what? Given off. What is being given off? Water is being what? Given off. Is that understood? Water is being given off. So, how do we know how the reaction will proceed? This is OH, this is OH. Now, OH plus OH. What are we expected to form here? This is H2O plus what? O. Do you know why? Because this O plus this O will give us 2 oxygen. Then this H plus this H will give us H2. True or false? True. Now, this H2O is what? Water. What is this? This is water. This is what? Water. Now, water will be given off. Then this oxygen will now form the linkage. Are you getting it? Between this and this. Whereas water is given off. This linkage here is what is called glycosidic bond. And all monosaccharides are linked together by this bond called the glycosidic bond. All monosaccharides are linked together by this bond called the what? Glycosidic bond. Yeah, they are linked together by the bond called glycosidic bond. So I can say that in this case, water molecule is given off. Water molecule is given off to form this. So when two glucose molecules come together, what are we expected to form? We are expected to form maltose. We are expected to form what? Maltose. The linkage that link them together, this linkage is what we call the glycosidic bond. It's what we call the what? Glycosidic bond. Okay? So we now know what a glycosidic bond is, right? And how it is formed. Now, how do we name them? How do we name them? The glycosidic bond. Now, we name the glycosidic bond based on the anomeric carbon. Are you getting it? Based on the anomeric carbon. Now, we know what anomeric is by this time, right? We should know what anomeric is by this time. We already know how these bonds are formed. Now, how do we name them is the next thing. I say we name them by what? Anomeric carbon. So, now, in this case, let's look at these structures very well. This is glucose. And we said also, we established that this is also glucose. Now, when you have two glucose molecules, what do you have here? This is OH, right? This is OH. Now, the first thing you need to know is, what kind of glucose is this? Is it beta glucose or alpha? Now, if you look at this very well, this is alpha glucose because the OH here is opposite this CH2O, this CH2OH. And this OH is facing down. We said when the OH is facing down, what do we call it? We call it alpha D glucose, or you call it alpha glucose, right? Now, this one also, what do you call it? This OH is also facing down. This is also alpha D glucose. This is also what? Alpha D glucose. Now, what do we now name this bond? Now, another thing is the numbering of these monosaccharides unit. This carbon 1, this carbon 2, this carbon 3, this carbon 4, this carbon 5, and finally this carbon 6. This is how it is numbered. Now, this carbon 1, carbon 2, carbon 3. You always number from the anomeric carbon. I will say this carbon carrying this O here is the anomeric carbon. Is that not so? So this carbon 1, 2, 3. Here is 4. Here is 5. And here is what? 6. So now the linkage is between what carbon and what carbon? You agree with me that it is between carbon 1 of the first glucose and what? Carbon 4 of the second glucose. And both glucoses are alpha and alpha. They are both what? Alpha anomer and alpha anomer. So if you want to talk about the bond that links these two things together, you now say that this is alpha 1 4. You saw the way I wrote it, right? Alpha 1 4 glycosidic linkage. Alpha what? 1 4 glycosidic linkage. Please take note of this. It's very important you know this. So the bond that links glucose and glucose molecule to form maltose is what? Alpha 1 4 glycosidic linkage. It's called what? Alpha 1 4 glycosidic linkage. Is that understood? Why? Because it was the OH of the carbon 1 here and the OH of the carbon 4 here that linked, and both of the glucose are alpha glucose and what? Alpha glucose. Are you getting it now? Is that understood? Now, assignment number 2. What you are going to do for me is give me 5 physiologically important glycoside. 5 physiologically important glycoside. Physiologically important. Okay? 5 physiologically important glycoside. You are going to give me them. Let me give you an example. Streptomycin is an antibiotic that is usually sold, right? Cardiac glycoside, glucovaline. I've already given you the name. Just go and write a little details on them. Okay? So that is for that. So we have alpha 1 4 glycosidic linkage. Okay? So let's talk about disaccharides. We are going to look at more of glycosidic linkage as time progresses, right? Now, let's talk about disaccharide. Now, the disaccharide consists of 2 monosaccharides that are joined by glycosidic linkage. They consist of how many monosaccharides? 2 monosaccharides that are joined by glycosidic bond, right? We discussed that before. Now, there are 2 types, namely reducing disaccharide. Now, reducing disaccharides are those disaccharides that are reduced or that reduced Benedict solution. Are you getting it? Those ones that reduce Benedict solution. That means the ones that are reducing sugars. An example is Maltose and what? Lactose. These are reducing disaccharide. Why non-reducing is sucrose and Cellulose. Please take note of this. We've discussed about reducing and not reducing properties of disaccharides before now, right? Please check that video for more details. So that is basically everything you need to know about disaccharides. For now, say they are when they contain 2 monosaccharide units joined together by glycosidic bond. For instance, this structure here is the structure of a disaccharide. This is a monosaccharide, this is a monosaccharide, and this is another monosaccharide, right? They join together to form 2 monosaccharide, which is called a disaccharide. They are classified based on their reducing properties. Some are reducing disaccharide, while some are non-reducing. Example of reducing are maltose and lactose. Example of non-reducing are sucrose and Cellulose. Now, let's look at maltose. Let's look at maltose. We've already discussed maltose before, right? We said this is the linkage. This is carbon 1 here, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Now, this structure of maltose is joined together by what? Alpha 1 4. We already discussed this. Glycosidic bond. Are you getting it now? Glycosidic bond. Now, lactose is not usually produced in the body, but is a breakdown product of starch. Are you getting it? When you break down starch, starch is a polysaccharide. Is that not so? we established that starch is a polysaccharide. So when you break down starch, it gives you, first of all, dextrin. Okay? Now, dextrin will be broken down to what? Maltose, which is a disaccharide. Then maltose will be broken down to what? To glucose. So you see how starch is broken down in the body. So maltose ordinarily is not produced by the body. It's a breakdown product of starch. Starch to dextrin, from dextrin to maltose, and from maltose to what? Glucose. Is that understood? So that is for maltose. Now, you know why maltose is reducing, right? We said for us to identify the one that are reducing is, look at the anomeric carbon. The OH present in the anomeric carbon, is it free? When we say is it free, it means is it available? Does it form any bond? For instance, this OH here is not available because it has formed bond with what we have here, right? So this one now is available. That is what makes maltose to be a reducing sugar, because this OH at the anomeric carbon is what? Available, reducing sugar. Now the next thing is isomaltose. Isomaltose. Now before we talk about isomaltose, first of all, this is a maltose. It means that this glucose unit, right? This is not glucose on its own. This glucose unit, because something has left glucose, right? And this is also glucose unit. Okay? Now, there's an enzyme called maltase. There's an enzyme called what? Maltase. Now, what maltase does is to break down maltose into 2 glucose units. Because we said maltose will be finally broken down into glucose, right? So maltase breaks maltose into 2 glucose units. Okay? So that is that for maltose. Now, the next thing is isomaltose. Isomaltose. Let's look at isomaltose. Now, what is the difference between isomaltose and maltose? Now, it's very easy. The difference is the linkage. Now, for this one, what is the linkage? The linkage is alpha. The linkage is alpha 1,4 glycosidic linkage. Alpha 1,4 what? Glycosidic linkage. Okay? Yes. But for this is alpha 1, or is it that right, comma 4? I love representing it like this. 4. Alpha 1 to 6 linkage, glycosidic linkage. Now, what does that mean? It means that this OH here, are you getting it? This bond here will not be formed here. Rather, the bond here will be formed on top of this CH2OH. Now, what we mean by that statement is, this is number 6, right? Instead of, let me try and see if I can draw a rough sketch. Now, let's assume this is the structure of glucose, right? Let's assume this is the structure of glucose with everything present. Is an assumption, right? Now, this carbon 1, 2, 3, our numbering 1, 2, 3, 4, 5, and then we have here CH2OH. Now, this is structure of glucose. Is that not so? Now, for that of maltose, that of isomaltose is from carbon 1, the linkage. So we have OH here initially, right? Now, from carbon 1, it will form a linkage with the carbon 6. Let me write it in such a way that this will be CH2OH, right? And then we have something like this. Now, this is what we have, right? This is what we have. Now, if you number also, this is carbon 1, 2, 3, 4, 5, and here is what? 6. So, this OH and OH, they can form H2O, right? They can form H2O, which is water. So, when this OH and this OH combine together, it will now form a bond, which is the linkage here. Okay, so the linkage will be somewhere around here. Let's just say it is from here. So you see that for isomaltose, it is not alpha 1,4, but what? Alpha 1,6 glycosidic bond. Glycosidic bond. Are you getting it now? Alpha 1,6 glycosidic bond. Now, there is another derivative somehow close to maltose, but it's called cellobiose or cellobiose. Anyhow you want to pronounce it. This is the spelling anyway. Cellulose. Now, what cellulobiose is beta 1,4 linkage, glycosidic linkage. Let's see GL to represent linkage. Now, what that means is very easy. What that means is the carbons that actually link in cellulose are this OH carbon here. Are you getting it? The OH carbon here is linking to the OH carbon of this other part here. So it's like you having beta glucose and beta glucose unit. So cellulobiose is for two beta glucose unit coming together. Are you getting it? And how do we identify beta? Is when the OH is on top here. So in that case, it means there will be no O here. The OH should be here, and here the OH should be here. So they will link from this OH here. Are you getting it now? To something like this. So the linkage will be in between here. That is for that. But that is not even our issue. Just know that for isomaltose, it is alpha 1,6 linkage. While for cellulose, it is beta. Not alpha this time, but beta 1,4 linkage. Is that understood? So that is for maltose. Now, the next structure we are going to look at is sucrose. Sucrose. Now, listen. Sucrose contains glucose and what? Fructose. Glucose and what? Fructose. Linked together by what? What kind of bond actually link both of them together? Now, first of all, let us identify the kind of glucose that is this, or the type of structure that is this. Is it alpha or it is beta? Now, the linkage here is between alpha glucose at carbon number, what carbon is this? Carbon number 1, and what? Beta fructose at carbon number 2. So you call it alpha 1 to what? Beta 2 glycosidic linkage. Are you getting it now? Alpha 1 to beta 2 what? Glycosidic linkage between the alpha glucose rather, and what? Beta fructose at position number 1. Now this position here is position number 2 for fructose, while this position here is position number 1 for glucose. Okay, we've already established that in our last class that the anomeric carbon or the anomeric carbon for fructose is usually number 2, while in this case for glucose is usually number 1, and sucrose is a combination of glucose and fructose. Okay, now sucrose is also called cane sugar, and it's a very sweet sugar. Are you getting it? It's a very sweet sugar, and it's what is usually referred to as cane sugar. Now, another thing that you should know is that sucrose is not a reducing sugar, and hence it does not form usazone. It does not react in usazone reaction. It does not form usazone. Gave you assignment on usazone to check on. I believe you checked on it. So sucrose is also called cane sugar. It's also sweet sugar. It is not reducing. It is not a reducing sugar. It is not what? A reducing sugar. And the linkage is alpha 1 to beta 2. Now, we have something here, inversion of sucrose. Inversion of sucrose. Now, I wouldn't want to go much into details. Let's analyze it together. Now, sucrose in solution normally. Sucrose in solution normally is dextrorotatory, because when we talk about inversion, we are talking about the optical activity. We are talking about the what? Optical activity of sucrose in solution. Okay? Now, when you have sucrose in solution, normally, it is let's say sucrose in solution. Let me use this to explain. Sucrose in solution, normally, we talked about dextrorotatory and optical activity. We say it can either rotate to the right, which is dextrorotatory, or to the left, which is what? Levorotatory. So sucrose in solution is dextrorotatory. Sucrose in solution, dextrorotatory. Now, sucrose is hydrolyzed into glucose plus fructose by an intestinal enzyme called sucrase. By an intestinal enzyme called sucrase. Now, this hydrolyzed mixture, which is glucose plus fructose in solution, is what is called invert sugar. So invert sugar is not usually just sucrose, but it is when sucrose has been hydrolyzed to give fructose and glucose in solution. That's what is called invert sugar. Now, you may want to answer the question, why is it called an invert sugar? Like, I mean, among everything in the world, why did they decide to give it invert sugar? It is called an invert sugar because, why? Because normally it is dextrorotatory, but this glucose plus fructose is what? Levorotatory. Now, the reason why it is like this is not that complex, but I don't think it's something that you should try and memorize now at year 2. But at year 2, you should know details, make research. Are you getting it? Go and know why sucrose is called an invert sugar. Know why. It's because the fructofuranose structure is not stable, so it simultaneously converts to what? To the reason is for fructose anyway. Like I was saying, I said fructose usually from fructopyranose, right? It is unstable. It converts straight to fructopyranose, which is strongly levorotatory. So overall, it will be levorotatory. But that I don't want to bother you with that details. All that details. Just know that inversion of sugar means a change in the optical activity of sucrose in solution when it is hydrolyzed to give glucose and what? Fructose. The mixture of glucose and fructose is known as what? Invert sugar. So if you are asked what is invert sugar, sucrose is the what? The mixture of glucose and fructose in solution is what is called invert sugar. Why? Sucrose normally is dextrorotatory, but sucrose is hydrolyzed by an intestinal enzyme called sucrase, which breaks it down into glucose plus fructose. Glucose plus fructose is an invert sugar, and glucose plus fructose combined, the net effect or the net optical activity is levorotatory. So at the end of the day, glucose is no longer dextrorotatory, but it will now be what? Levorotatory. I believe it all makes sense now, right? So that is for inversion of sugar. Now let's look at lactose. Let's look at lactose. Lactose is between galactose. Lactose is between galactose and, of course, glucose. Joined together by what kind of bond? Now, you agree with me that this is position number 1, and this is position number what? 4. So the bond is 1,4 glycosidic bond, right? 1,4 glycosidic bond. But what kind of 1,4 glycosidic bond? Now, this OH was initially here. This is the anomeric carbon. So when the OH is up, what did we say it is? Because OH was here. OH was here. That was what combined to give O here, right? Now we said that when you have the OH at the anomeric carbon on top here, what did we say it is? It's beta. So this is beta galactose. Beta galactose. Now look at glucose very well. Can we actually make sense from it also? Now you see that the OH of, first of all, where is the anomeric carbon? This is the anomeric carbon, right? Now this OH is on top here. We say when the OH align in the same direction with the CH2OH, like it's on top here, we call it just like something that we can easily use to spot it, right? We say this is also beta. So this is beta D-glucose. So we can say that beta D-glucose and beta glucose. So we can say that the linkage that link galactose and glucose together is what? Beta 1,4 glycosidic linkage. Beta 1,4 what? Glycosidic linkage. Are you getting it now? Beta 1,4 glycosidic linkage. Now there is a disorder that is called lactose intolerance. Now there is an enzyme, the enzyme that will split lactose into the component monomers, which is what makes it up. Beta galactose and beta glucose is what is called lactase. Is what is called what? Lactase. This enzyme splits it down to give us beta galactose and beta what? Glucose. Now there's what is called lactose intolerance. Now lactose intolerance is a disorder in which this enzyme lactase is unable to break the lactose down into its component monomers, which are beta galactose and beta glucose, thereby leading to what? Incomplete digestion. Thereby leading to incomplete digestion of what? Lactose. Because before lactose can be digested by the human body, or by the intestine or in the intestine, first of all, lactose must be broken down into galactose and glucose. Are you getting it? Lactose must be broken down into galactose and glucose. So lactose intolerance is when the enzyme we are looking at here is what? Lactase, is unable to break down this lactose into galactose and glucose, thereby leading to what? Incomplete digestion of what? Lactose. And some of the symptoms are bloating. Bloating is like you see something like air in your stomach. You never chop, but your belly they do it like say you full. Are you getting like air? And you're just now only air to your belly. They mess any mess. Are you getting it now? That is what is called bloating. Then we have, it can also give some signs of it are diarrhea. Some signs of it are diarrhea and bloating. Okay, so that is what lactose intolerance is all about. It's a disorder, most especially in children. No children take milk and dairy product, and lactose is found in dairy product like milk. So I may ask you, what monosaccharide or what disaccharide is found in dairy product like milk is what? Lactose. Cane sugar is what? Sucrose. Sucrose is also used to sweeten food. It's mostly used as a sweetener. Why? Because it's what we call sweet sugar. Sucrose is called a sweetener in most pharmaceutical products and even in food. For instance, most of the syrup we take, sweetener, they contain sucrose, 66.6% sucrose. Those of us in pharmacy are going to learn this in second semester. Syrup contains 66.6%. They are mostly used as sweeteners in pharmaceutical products. Okay, so that is that for sucrose. I believe we've touched everything about sucrose. And then lactose also. We talked everything about lactose. Is there any other one again? Now we have polysaccharides. Now polysaccharides are classified into two. We have what is called the homopolysaccharides and the heteropolysaccharides. We have what? Homopolysaccharide and what? Heteropolysaccharide. Now we are going to look at homopolysaccharide in this lecture. Now, as name implies, homopolysaccharides are those polysaccharides that consist of what? That consist of only one monomer. that consists of only one monomer. We say polysaccharides are thousands of monosaccharides joined together. Are we getting it? Thousands. We say when it is above 10 and above, it becomes a polysaccharide, but most times they are usually thousands in numbers. Are you getting it now? So whenever it contains only one monomer, that is to say the monomer that makes up the polysaccharide just one. For instance, if you have glucose plus glucose, only glucose joined together, glucose, 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 everything glucose. That polysaccharide is called homopolysaccharide. Now, they are classified into two. We have glucosan or glucan. We have glucosan or glucan. You can also call the glucan. And then we have fructosan. Now, as name implies, glucosan or glucan means they contain only glucose subunit. Means they contain only glucose what? Subunit. Fructosan means they contain only fructose subunits. Are you getting it now? So all polysaccharides that contain only fructose, they are called fructosan. For instance, inulin. Inulin is a fructosan. Okay? Inulin is a fructosan. It contains only fructose. Now we are going to look at them one after the other. Glucose, starch is a glucosan or glucan. Do you know why? Because we said starch, when you break it down by an enzyme called amylase, it breaks it down to give us dextrin. Dextrin is further broken down to give us maltose. And maltose is broken down to give us what? Glucose. So you see that when glucose combine together, reverse order now, it will give maltose. Maltose combined together, it will give dextrin. Dextrin combined together, they will give what? Starch. Is that understood? So you see that at the end of the day, the end product is what determines what it's actually made up of. So starch is hydrolyzed completely to give glucose. It means that starch contains only glucose molecule joined together. Hence, it is a homopolysaccharide. Homopolysaccharides are those polysaccharides that contain only one monosaccharide joined together by what kind of bond? Glycosidic bond or glycosidic linkage. It makes sense, right? It makes sense. It makes sense. So let's look at each of them one after the other. Now I have a table here. The table, we have starch. We've talked about starch just now. We said starch is what? A monosaccharide, is a polysaccharide, contains of glucose subunit. So you now say the unit subunit contains glucose. Short description. Now the starch contains two parts. Are you getting it? The starch contains two parts. Now the two parts are, one is water soluble. So we are going to use water S to indicate water soluble. The part that is water soluble is called amylose. It's called what? Amylose. And amylose, the kind of linkage that joins amylose together, that joins, amylose now is like glucose coming together, because we said they are made up of glucose subunits. So when glucose come together, they form amylose, right? Now the amylose part of starch contains glucose joined together by alpha 1,4 glycosidic linkage. Now the next part is amylopentene. The next part is what? Amylopentene. Now amylopentene is water insoluble. Let's take it like that. It's water insoluble. And the linkage is alpha 1,6 linkage. The linkage is what? Alpha 1,6 linkage. So that is for starch. Now starch is the major reserve. Somebody is calling me. Now food store carbohydrate plants store carbohydrate in form of what? Starch. We all know this. And then in higher animals also in form of starch. Now, another thing that you need to know is this starch, I've discussed it before, that starch is broken down by an intestinal enzyme called amylase. Now, it breaks it down to dextrin, right? Then we say from dextrin to what? To maltose. Then from maltose to what? Glucose. Now, one thing you need to know is this amylase only acts on alpha 1,4 linkage. It only acts on what? Alpha 1,4 what? Linkage. And that is the reason why cellulose, fibers, tapioca are not easily vegetables. Sometimes when we eat vegetable like ruminant animal, you go to the toilet, you cheat out your vegetable too. This looks a little bit awkward. But anyway, you cheat your vegetable. Why? Because vegetable, which are cellulose in most cases, they contain beta 1,4 linkage. And the amylase, which is the enzyme in our body that breaks down this starch, it only breaks down alpha 1,4 linkage. Are you getting it now? Now note that this aminopentane part of it is a branch. That is to say, after you must have gotten like 20 to let's say after you must have gotten to like 20 to 30 glucose joined together by alpha 1,4. Something like, if this is a glucose, another glucose, of course you know this is alpha 1,4, right? This something like this is alpha 1,4. Now the aminopentane now is now something like here. You now have another branch on top here. Are you getting it now? In this case now, what does it mean? It's alpha 1,6, right? Because we say 1,6 is usually on top. So you now continue alpha 1,4, then another one on top like that. So this one now is like a branch. Are you getting it now? So that is for everything you need to know about starch. Now, do we need to talk much about dextrin? Do we need to talk about much about dextrin? What am I speaking? Oh my God. Now, we said dextrin are hydrolyzed product of starch. They are hydrolyzed product of starch. Now, this is to say, when you break down starch by either, when you hydrolyze starch by either an HCl, strong acid, it gives what? Dextrin, or an enzyme. Are you getting it? It gives dextrin. Then from dextrin to what? Maltose. So just note this, okay? Now, before it will break down to give us dextrin, we have other intermediate like amylodextrin, we have erythrodextrin, then we have atrodextrin, which can be identified by Benedict's test, okay? Can be identified by iodine coloration, rather, not Benedict's test, by iodine coloration. But that one does not even really, I don't think you have to buzz yourself with those details for now. Just know that starch is hydrolyzed to what? Dextrin. Are you getting it now? Then from dextrin to what? To maltose. Then from maltose to glucose. That is to say that dextrin is a polysaccharide, but it's not as polysaccharide as starch. What I mean is not as polysaccharide. What I mean is it does not have much monomers joined together. It's not as large as those of starch. Then the next one is dextran. Now, dextrans are polymers of glucose produced by microorganisms. They are polymers of glucose produced by microorganisms. They are produced by microorganism. Okay? Now, another thing that you need to know is that they are used as plasma volume expander. Dextran. I will ask you this question in your quiz. Take note of it. Plasma volume expander in transfusion. Go and get idea about this. Plasma volume expander in transfusion and in gel filtration or chromatography. In transfusion, then and chromatography, that is gel filtration. That is for Dextrans. The next one is inulin. Now we said inulin is starch, dextrin, they are all glucose. Inulin is fructose subunit. So if fructose subunit, what would you call it? You call it a fructosan. What would you call it? You call it a fructosan. Now, inulin is not utilized by the body. Not utilized by the body. Not utilized by the body. But it is used to check kidney functionality. Are we getting it now? It is used to assess kidney function through measurement of glomerular filtration rate. Glomerular filtration rate. When you come to second semester in physiology, you learn GFR, glomerular filtration rate, talking about how much of urine and blood is filtered by what? The glomerulus by a particular time. There's a formula for solving it, which have people forgotten? Yes, but I'll go and make more research on this. GFR is glomerular filtration rate. Fructosan is used in assessment in kidney for measurement of glomerular filtration rate. So the next one is glycogen. Glycogen is a carbohydrate. We can say that animals stores carbohydrate in forms of what? Glycogen. Animals stores carbohydrate. Animals stores carbohydrate in form of glycogen. Okay? They store carbohydrate in form of glycogen. Now, glycogen is found in plants that do not possess chlorophyll. We already know that. And glycogen is present in this one. You must know it because you are going to do it in biochemistry second semester. It's present in large amount in the liver. So when your body lacks carbohydrates, are you getting? When it lacks energy, some of the glycogen that are stored in the liver, you know, we say glycogen. Glycogen contains glucose units also joined together by alpha 1,4 linkage. Okay, it's like the counterpart of starch for animals. You know, starch is like for plants. Animals, glycogen. Are you getting it now? It's also formed by alpha 1,4 linkage of what? Glucose. Alpha 1,4 linkage of glucose. Now, what was I saying? Okay, I was talking about the process of converting glycogen. Now we say this is glycogen, right? What does it contain? Glucose, right? And it is stored in large amounts in the liver, followed by muscle, etc., and brain. Are you getting it? Liver followed by muscles and brain. Now, when this is like a reservoir, a storehouse. Let's take it that way. It's like a reservoir, a storehouse. Now, when your body lacks energy, that means there is no glucose present. There's an enzyme that is called glucagon. There's an enzyme called what? Glucagon. So when your body lacks glucose or energy, there's an enzyme called glucagon which will break down glycogen to give us glucose for generation of energy. And this process is called glycogenolysis. It's called what? Glycogenolysis. So the process in which glycogen is broken down to glucose for generation of energy by enzymes, glucagon, is called what? Glycogenolysis. You are going to learn it when you second semester carbohydrate metabolism. Okay, but that should not be your problem for now. So that is for glycogen. Glycogen also contains glucose. Animals stores carbohydrate in form of glycogen, and the linkage that join the glucose molecules together is the alpha 1,4 linkage. It's like the counterpart of starch in animals. Also, there are some plants, especially the ones that lack chlorophyll for manufacture of their own food. There are some of these plants that also possess glycogen. So it's not exclusively reserved to only animals, but some of the plants that lack chlorophyll, That means they cannot manufacture their own food. Also has what? Glycogen. Are you getting? Also stores carbohydrates or energy in forms of what? Glycogen. So that is for that. Now the next one is, I think, cellulose. Now cellulose is where you find your fibers, tapioca. Now cognosis second semester talked about fibers. Now the chief constituent of most fibers is cellulose. Now most vegetable contains cellulose. The difference between cellulose and starch is just the kind of anomer. Cellulose is beta 1,4 glycosidic linkage. Beta 1,4 glycosidic linkage. Okay? Now, listen. Cellulose, like vegetables, they cannot be digested in our intestine because we lack the enzyme cellulase that will break it down. Are you getting it now? We lack the enzyme what? Cellulase that will break cellulose down into glucose for utilization by the body. Humans cannot digest cellulose, but animals, ruminant animals, is it ruminant or not ruminant? Ruminant animals like let's say goats, those ones they chew grass, chom 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 chom, and they poo poo as black poo poo, black shit, because that grass digested very well. But you as human, if you eat that grass, there are some vegetable ugu. When you buy them in the market, you discover that when you go to the toilet, you see your ugu as it is in your toilet. Why? Because our stomach, when we were young, they used to say there's an engine in the stomach that grinds our food. That engine is not able to grind the vegetable. Are you getting it? They are enzymes. They are what? Enzyme. Now, the enzyme that is found in our body is amylase, which we said breaks down starch to give us dextrin. Now, amylase only acts on alpha 1,4 glycosidic linkage. Amylase only acts on what? Alpha 1,4 glycosidic linkage. Okay? It only acts on alpha 1,4 glycosidic linkage. It does not act on beta. So amylase is not able to break down cellulose in our body to give you us glucose. That is the reason why our body cannot digest cellulose. Most fibers are made up of cellulose. The chief constituent of most fiber is cellulose. Vegetable fibers, they are what? Cellulose. So that is that for cellulose. Now, cellulose, when you break down cellulose, now it gives a disaccharide called cellobiose. I mentioned this when I started this lecture by saying that starch gets to dextrin, then from dextrin to a disaccharide called maltose, right? But cellulose, we give cellobiose as the disaccharide. Now, the difference between cellobiose and starch is just this. Now, starch or maltose, the difference between cellobiose and maltose is this. Maltose is alpha 1,4 linkage, which we've discussed before, while cellobiose is what? Beta 1,4 linkage. That is the only difference. Are you getting it now? That is the only difference. So that is that for cellulose. I believe we've done justice to cellulose, okay? Now, the next thing is chitin. Chitin is actually comprised of monomeric. It's actually composed. Chitin is actually composed of derived monosaccharide N-acetyl D-glucosamine units joined together by beta 1,4 glycosidic linkage. It is found in exoskeleton of most invertebrate like insect, crustaceans. You may be asked, the exoskeleton is they are the skeleton outside, right? Like crustaceans and what? And insect. They ask you, the skeleton of crustacean like insect consists of what? Chitin. is joined together by N acetyl D-glucosamine. Are you getting it? You don't even need to memorize it, but just know it. N-acetylglucosamine units, they are joined together by beta 1,4 glycosidic bond. Okay, you know N-acetylglycosamine later when we're talking about polysaccharide. So this is where we are going to end this lecture for today. I believe you learned a lot in this, right? Now what you are going to do for me is practice more. Practice more. Are you getting it now? Give me the structure of ascorbic acid as your assignment, and thank you for your time. God bless you.